Hi everyone, let's graph one period of the function y equals to secant of 1 over 2x plus pi over 3. As you can see, it involves some translation. But the good news is that it's going to be taken care of when we construct the guideline graph. What is the guideline graph for this function? For that, we just have to recall that secant is the reciprocal of cosine. So cosine is going to be the guideline function. And not just the basic cosine function, but the function that has exactly the same structure as the given one. In other words, in the first step, we have to sketch the graph of the function y equals 2 cosine of 1 over 2x plus pi over 3. I literally copy all constants from the given function. Okay, so let's graph this cosine function. First, I'm going to describe it. Its amplitude is 2. It's not reflected. Frequency is 1/2. And the period is found by taking 2 pi and dividing by 1/2. So that is 2 pi over 1 times 2 over 1, or 4 pi. So first I'm sketching the cosine function without translation. Let's label the horizontal axis. Period is 4 pi. So the key x values will be pi, that is 1/4 of the period, 2 pi, 3 pi, and then 4 pi. Since it's not reflected cosine function, the first key point will be the maximum point. So it's going to be at 2. Then it goes down to 0 point, then minimum, another 0, and maximum point. So far I've grabbed the function y equals 2 cosine of 1 over 2x. Now it has to be shifted to obtain the graph of the guideline function. Let's calculate how far and which direction it has to be shifted. In other words, let's find the phase shift. For that, I'm taking the entire expression inside the parentheses, 1/2 x plus pi over 3, and I set equal to 0 and solve for x. So 1/2 x equals negative pi over 3, if I subtract pi over 3 from both sides. And now I have to multiply by 2 over 1 on each side to get x by itself. So x equals negative 2 pi over 3. That will be the phase shift. That means that each of those key points I have to move 2 pi over 3 units to the left. I'm going to use this table to compute the shifted x values. By the way, if you need more practice or you need to refresh this process, be sure to watch videos on graphing the sine and cosine functions using horizontal translation. Okay, back to my table. In the first column, I listed the x values where the key points of this cosine graph are right now. And now to calculate where these points are going to be positioned after the shift or translation, I will need to subtract 2 pi over 3, the phase shift, from each of those original x values. Okay, so I did all the math and these are the values I got. Next, I'm going to label them on the horizontal axis. So here they are. And now it's time to shift all the key points to obtain the graph of the guideline function. The maximum point shifts left, and now it's here. 0 point is going to be at pi over 3. Minimum point will be at 4 pi over 3 as I shift it to the left. Next 0 will be at 7 pi over 3. And finally, the maximum point will be at 10 pi over 3. Now I'm going to reconnect the points. Okay, so what you see in green is the graph of the guideline function y equals 2 cosine of 1 over 2x plus pi over 3, and we used horizontal translation to obtain it. And guess what? The hardest part and the most time-consuming part is done. What I'll do next before moving on to the second step, I'm going to erase this blue graph. I don't really need it anymore. And as you can see, I also erased the original x values so that they don't confuse me. We're ready to move on to steps 2 and 3. In step 2, we need to sketch the vertical asymptotes of the secant function. So the vertical asymptotes are always positioned at the zeros of the guideline function or in other words, at the x-intercepts of the guideline function. They go through the x values for which the given secant function is undefined. And finally, step 3, the easiest step. Now we need to sketch U-shaped branches of that secant function. U-shaped branches will be positioned in between the asymptotes. Since I only ended up with 2 asymptotes, well, this is one full branch that I'm going to place in between them. As you remember, the branches of the secant and cosecant graphs touch their guideline functions at the minimum or maximum points. And since I don't have any other asymptotes, I can do 2 half branches on each side. And altogether, that creates one period of the given secant function. Now, if you really want to have another full branch, then you need to extend the guideline graph until next 0 on the right-hand side or on the left-hand side. Since I have some space on the right, let me just demonstrate how it's done. Well, I can see that in between 2 key values, I have exactly pi units. And that's actually we already figured out at the time when we graphed the guideline function. So that means that the next x value that I need will be 13 pi over 3. And that's where I will place 0 of the guideline function. Now I can extend it and place another asymptote. This way I'm able to obtain another full branch of the secant function. So these are the steps. As you can see, step 1 is the most time-consuming, but you really want to pay a lot of attention to that step, not to make any mistakes. And then step 2, sketching the asymptotes, and step 3, sketching U-shaped branches, are the 2 easy steps. Don't forget that vertical asymptotes are always placed at zeros, or the x-intercepts of the guideline graph. And then U-shaped branches always touch the minimum and maximum points of the guideline graph.